So we're going to look at a problem that involves enlarging a 4x6 photo so that the width becomes 10 inches. So we'll call this side the width, and we want to see what the new length, or I guess we call it height, will be. We're going to look at a couple different ways to solve this problem, and what we're doing here is proportional reasoning. So while this is a photo enlargement problem, this would work in any type of problem where scaling is involved. For instance, if there's a model built and you have a scale on the model, you can scale up to what the actual size would be. Or looking at a map is a common example where they give you 1 inch is equivalent to however many miles, and you need to figure out the distance. So this is one specific problem, but it can generalize to a whole bunch of types of problems. Now, because we have to maintain a ratio between the two photos, otherwise it'll become distorted, one way of solving this is to set up what's called a proportion. A proportion is where two ratios are equal to each other. One way we might do that is we might set up the ratio of the sides. So 4/6 for the small photo is equal to, instead of using a question mark, let's use a variable, say x is equal to x/10. Now once we have a proportion, once you have two fractions equal to each other, one quick way of solving is doing what's called cross-multiplying. That's multiplying across with the denominators. And I use arrows there to show where my multiplication is at. So 10 times 4 is 40. 6 times x is 6x. And now we have a nice linear equation that we can solve by dividing both sides by 6. Because those cancel, and we get x equals 40/6. Or we can reduce this down to 6 4/6, or 6 2/3. And remember, this was in inches, so there's our new height. I'm going to show you one more way of setting up the proportion that would have also worked. One thing we could also do is we could set up the proportion by matching up corresponding sides. So one way of thinking about this is 6 is to 10, so 6 goes to 10, as 4 goes to, we'll call it again, x. Now, notice, this is important, that with a proportion, the same photo is either lined up vertically, 4 and 6 are both on the small photo, or horizontally, 4 and 6 are both on the small photo. That's important. You wouldn't want to have them matched up diagonally. They have to be matched up horizontally or vertically for this to work. Now again, we can cross multiply, and we get 6 times x on the left hand side equals 4 times 10, which is 40. And we know from solving this before that x is going to be equal to 6 2/3 inches. So that's two ways of setting up a proportion. A third way of solving these kind of problems is called scaling. And what scaling involves is looking at the scaling factor of going from one photo to the other. This can actually be thought of as a percent increase as well. So the question is, what is 6 getting multiplied by in order to get 10? So what we're going to look for is that scaling factor. So we're going to take 6, and it's getting multiplied by some scaling factor, let's call it r since we've already used x, to get 10. Now we divide both sides by 6 to get our scaling factor, and we get r equals 10/6, or 1 4/6, or 1 2/3. Or we could also leave it as 5/3. That's our scaling factor from going from one photo to the other. So to determine what our new side would be, what we would do is we take the other side, 4, and multiply it by our scaling factor of 5/3. Multiplying across, remember that we think of this as 4/1, so 4 times 5 is 20. 1 times 3 is 3. So we get 20/3, which is 6 2/3 inches. So there's 3 different ways of looking at this problem. And again, we did this for the photo problem. But this works in any kind of scaling problem where proportional reasoning is involved.